Hey guys! In today's video, we'll be going over a simple way to memorize trigonometric identities. To do so, we first must remember this phrase. Wait a sec, you can't throw a tantrum unless you sing for the costly cot and cosecha. The letters highlighted in red represent the trigonometric functions: secant, tangent, sine, cosine, cotangent, and cosecant respectively. From here, we will draw a hexagon. On this hexagon, we will put the trigonometric functions on each vertice, in the order as seen in the phrase we had before. We start from the left and bottommost vertice, and then go clockwise. So following our phrase, it will be, wait a sec, you can't throw a tantrum unless you sing to the costly, cot, and cosecha. Finally, put a 1 in the middle of the hexagon. From this image, we can actually extract a lot of information about the relationship of these functions and their identities. To begin, if we start from one of the vertices, let's say tangent, and go clockwise to the next two functions, we can see that sine over cosine equals tangent. Go further, and we see that cosine over cotangent equals sine. You can do this throughout the hexagon, going clockwise, and see that the quotient of the next two numbers from a vertice equals that starting vertice. But what happens if we go counterclockwise? Well, the same principle applies. Starting from tangent again, but this time going anticlockwise, we can see that secant over cosecant equals tangent. Similar to going clockwise, this holds true throughout the hexagon as we go anticlockwise. Now, how does this 1 play into our shortcut? Well, if we multiply opposite vertices, we get 1. So sine times cosecant equals 1, cosine times secant equals 1, and tangent times cotangent equals 1. The reason that multiplying each function by its diagonal function equals 1 is actually an additional trick in our hexagon. Diagonals multiply out to 1 because they are reciprocals of each other. Therefore, sine equals 1 over cosecant, and cosecant equals 1 over sine. Another trick can be done with complementary angles, which are angles whose sum equals 90 degrees. Straight horizontal lines can be drawn to see this complementary angle relationship between trigonometric functions. This line between sine and cosine tells us that sine equals cosine of 90 minus theta. Flip the line in the other direction, and we get cosine equals sine of 90 minus theta. The same relationship can be seen between tangent and cotangent and secant and cosecant. An additional trick for our hexagon is taking three functions next to each other. Let's say tangent, sine, and cosine. Now, if we multiply the first and last function, in our case tangent, and cosine, we get the middle function, or in this case, sine. This can be done with any three continuous functions that are next to each other in our hexagon. Our final trick will be using the 1 in the center once more, and the 6 triangles that make up our hexagon. If we focus on only 3 triangles, we can go clockwise within each one, starting with the top left position. Here, if we use sine, cosine, and 1, we get sine squared plus cosine squared equals 1. Using tangent, 1, and secant, we get tangent squared plus 1 equals secant squared. And using 1, cotangent, and cosecant, we get 1 plus cotangent squared equals cosecant squared. If we do the same thing, but now go anticlockwise, we do a minus sign before the second term, and now go in the direction the arrow is pointing us towards. Now we do 1 minus cosine squared equals sine squared, and so on. I hope this video helped you to easily memorize trigonometric identities.